Welcome back everyone to another Kerbal Space Program video, and today's Kerbal Space Program video I'm going to be adding some new parts to the space station that I have in low Kerbin orbit, or it's not really low Kerbin orbit, it's just an orbit around Kerbin. You might know that the part that I'm adding, or that I'm referring to, is a gravity ring. So I've been looking forward to putting a gravity ring on the space station for a while, just because they're pretty interesting and they're pretty difficult to do, and you know, it's always fun to have a nice challenge. So yeah, that's what we're doing in today's video. Right now we're starting off with the construction of the gravity ring. I wanted the ring to be pretty big, you know, just so it would definitely stand out in the space station. I didn't want it to be too small so that you could kind of just overlook it easily. I wanted it to be really eye-catching, so we went for a very large ring. You might, if you want to know how I kind of did that whole like symmetry thing where I got tons of symmetry on there, you could probably find a better explanation somewhere else on YouTube on how to do it than I could ever provide. But yeah, so right now just kind of constructing, you know, the main part. This stage here is going to be what's responsible for docking it to the space station. You might notice that I added some parts to that cargo bay there, and what I wanted to do using that new feature that we have where we can construct things in orbit, or not in the vehicle assembly building, I wanted to add a probe core and some batteries and solar panels to another module that we have on the space station that needs to be deorbited, but in the end it didn't end up working. So I think I just ended up detaching it. I'm not sure. But yeah, here what I'm doing is I'm building like this truss structure out of these. I think these are, I'm not sure what size fuselage this is, or I don't know what size fuel tanks this is, but I'm basically building this thing that goes through the rings like that so that we can strut everything together and it doesn't wobble around completely. Yeah, so this kind of structure that I'm building that I was just talking about is really important, because if you don't have it, the ring will wobble around a lot and you won't really have any control. But it's also kind of complicated sometimes, because you have to make sure that it decouples well. I just launched it and put the gravity to 0 to make sure that it would decouple. And as you can see, it did, but it also exploded, so I had to kind of edit that design a little bit. So I just made sure that there was no clipping or no extreme clipping with the fuel tanks, and that seemed to solve the problem. As you can see there was just a little bit of some explosion, but that's fine. I'm fine with that. So now we can start working on the lower section. I changed it out, as you can see, for Rhino, just because we didn't need a lot of delta V. That main sail engine would provide tons of delta V for us, but we didn't need that delta V, so I just switched it out for something with a higher thrust. That way it'd be easier to maneuver this craft. Here I was switching out those Mastodon engines for vectors, because those vectors will be used while we're in space, and they have lower thrust per engine, but they have higher vectoring range, so we can have more control with this massive craft. Here you can see I'm adding some some SRBs on the side, and you can see I quickly faded across, because it was at this point, or it was later during the construction process, where I felt as if I needed to add some more engines, so I just added an extra Mastodon there at the bottom just to give us some more thrust. I added one on each side. But yeah, with that said and done, we can go ahead and launch. So, you know, nothing too crazy. We need to be really careful when with a payload of this size, especially when we have a lot of weight towards the top and it's going to become really top heavy. We need to make sure that we're not pitching over too aggressively, or else you'll just end up flipping. And that's why it's also good to have engines with good vectoring range, like the you know, like the Mastodon engines. They have pretty good thrust vectoring. So yeah, we just exhausted our first two stages, and now we're on the vector engine stage. And you may notice something that was not in the time-lapse was all of those fuel lines that run into that vector stage from the truss structure. Since the truss structure there is made out of fuel tanks, it obviously houses fuel. So we can use that fuel and run fuel lines into that main stage there, just to get the most out of this craft as possible. And then once we use all of those fuel tanks, we can kind of just eject them just like that. I wanted to do it one by one just to make sure everything went smoothly. I kind of had to do some time warping with RCS and yeah, some RCS there to kind of tilt the craft and move it back away from them so we can get them away from the craft before we do any burns. Now it's when we're starting like the docking process, or when we're trying to get a rendezvous with the space station. First, we need to adjust our inclination, which is what I'm doing here. This is standard procedure. It always happens at any docking process. You always need to adjust your inclination first, and then you can plan your encounter, which is what I just did. So once we line up with the target node, we can time warp over to our maneuver and get ready to burn for it. And just like that, we got pretty accurate. We're down to 0.3 kilometers. This craft, you could probably tell, is huge. So the RCS that I had on there was nowhere near enough. So docking this thing was a huge struggle. It was really, really annoying to get everything aligned and stuff. You can see there, like, everything just keeps spinning out of control. I could never get it down to like less than a half a meter per second moving from the target. And if you've never done docking before, you know that you usually want to get your position or your speed relative to the target about 0 meters per second before you actually start your docking process. But here you can probably tell I only got it down to like 0.2, which is not too crazy, but you know, as you start to burn and gain more speed, it's gonna have pretty drastic effects. But you know, we got it done, and it worked, or else I wouldn't be uploading this video. But yeah, we're starting to move towards the space station, and we're pointing retrograde towards it so we can end up slowing down. And like I keep saying, we never really get down to 0 meters per second. So I just detached that stage there as we were rotating to keep it away from the craft. And now we can actually start moving towards the vessel. If you want an explanation on how to dock stuff, you probably shouldn't be attempting gravity rings if you need one. But if you want an explanation, you could probably find some videos on YouTube. I like to use a method developed by Matt Lown. He's another really good KSP YouTuber. I really recommend his channel if you haven't heard of it yet. But basically what you do is, if, for example, in this case, if we're piloting the docking, if we're docking the gravity ring and we're piloting the ring, you set the docking port you want to dock to as your target. Then you switch to space station and set the gravity ring as your target. And then, as long as you're both pointing towards the target on the nav ball, they'll always stay pointing towards each other. And that's a really easy way to get your dockings done. So yeah, so we got everything all docked. I kind of just faded across there to when we detach this booster, because there was a lot more stuff that was happening. But yeah, so now we're just going to deorbit this booster, and we can land it nice and safely. I didn't put any landing legs on it, but you know, we landed it in the ocean anyway, so it was fine. We have parachutes on there as well, and I ended up using some thrust from that Rhino engine just to make sure we got a nice soft touchdown. We ended up touching down around like 5 meters per second, and yeah, it worked out pretty well. But yeah, that was the whole video. That went by really fast. Yeah, that was the whole video. I hope you enjoyed. If you did, consider liking the video, and if you've enjoyed anything I've been making so far, consider subscribing. I'd really appreciate it. But yeah, check out some other videos that I've made, and yeah, I'll see you guys in the next one. Bye.